to this last lecture in this course. So I'm going to go out on a limb and share some closing thoughts related to how ML as a field has evolved and how the operational aspects will be closely tied to the arc of evolution, how it's moving forward. I've intentionally also called out the fact that these thoughts are as of mid 2025 because it's quite dangerous to do any kind of prediction or trending given the pace at which the AI world is moving. Nevertheless, I think it's quite instructive to look at how the systems themselves have evolved um, and and see how you can contribute to that, right? As engineers, as data scientists, as operational executives, etc. So, if you really peel the layers back, and I'm borrowing from uh, academia as well as other AI thought leaders here um, in summarizing what I'm doing right now. So the first wave of software, uh, you can think of it as software 1.0, emerged from the need for business leaders to have certain problem statements be solved. So they would give requirements, and those requirements would manifest as English language documents or discussions or talking points, and then they get coded up using teams of developers. Let me bring out my laser pointer here. Yeah, teams of developers who would code those requirements up, and then they would produce software, and that software would then get used and then produces some kind of a work output. Then the feedback from that goes back to the business teams. They ask for some changes. The changes come back into code requirements, and the code requirements get coded up, becomes new versions of software, etc. So this cycle is how software 1.0 operated. So if you really think about a simple problem like spam detection, um, one of the most earliest ways of solving for it was using rule-based approaches. So the rule would be something like, if the domain for the sender of the email is from Russia, then as an Indian or as an American, I'm not expecting that to be the common case. So therefore, I'm going to mark that email as spam. As you can imagine, that's not the right approach all the time. It results in a lot of heartache for, let's say, Russian citizens living abroad or living in India, living in the US. Nevertheless, it was a approach which is better than having no approach. And that's how software 1.0 systems were built, right? Using specifications like this, they would get feedback, and the feedback would say, let's say, for instance, that, hey, this discounts the fact that Russian citizens communicate in Russian language with their relatives who also are living in Russia. So we can't mark those emails as spam, right? That will be a feedback, and the business would come back and change the requirement or add some complexity to the requirement, etc., etc. That's how these systems evolved. Now, let's go to what data science brought to the table. Unlike um, formal science, right, which had formula like a predictable, consistent, deterministic model of how the real world worked, right? Data science um, is a proxy interpretation of how real world systems work, right? Using data as the learning mechanism. So you don't know the science behind it of why certain phenomenon occurs. There is no formula to explain, but you've got a bunch of observational data, and you're trying to mathematically fit a representation, right, on top of that observational data that explains most of that observational data. And in choosing the mathematical representation, you also constrain the power of what the representation can do. Like if you choose a linear formulation, then you can at best learn only a linear model. If you choose, on the other hand, an extremely complex formulation like a deep learning network, then it has much better power to explain, but it still is constrained by what the deep learning architecture can, at the end of the day, learn potentially. So it's not a pure science. It's science that's informed from experimental data or observational data. That's why it's called data science. And what this data science did was, instead of relying on word of mouth feedback, the data that's being produced from the usage of the software, which is in terms of monitoring, observability, outputs, etc., errors, logs, all of that gets collected, and these data sets are of different forms, different formats, right? Binary data sets, audio data, image data, text data, etc. And then they all feed into a step which looks at analysis of this data, right? And these are data scientists like you and me trying to do that and then producing outputs for the business to consume. And then the business would go change the requirements like how they've always done. And this results in code where the data model gets used in a particular software setting or not, right? So that's the arc of data science, and that's exactly how we have learned data science. So what did software 2.0 do is they took the models themselves which are getting produced from data science, embedded the models into the software such that I no longer need to code the rules or the logic by myself, right, as coders. Instead, I have um, code which goes and learns a model, right, which is what an ML model training and model selection does, right? It goes and learns a model, and the model is the one that's responsible for, interpreting rules, coming up with various explanations of why certain emails are spam and things like that, right? So in this case, a spam detected ML model gets built. So the code itself is the model, and the model gets used in the software. You still need software because you still need to do a lot of actions on top of this, right? You can't just use the model itself as a software. The model will only say yes or no, right? And then the software will interpret that and accordingly take some action on top of the, spam email or non-spam email. So the software is now ML infused, right? More importantly, business no longer needs to come and define rules for you. The rules no longer need to be implemented by you, right? You can actually build models which goes and learns from the data, the patterns which are necessary. So this is how software 2.0 worked, and Google's spam detection model that they launched with Gmail was so powerful compared to all the earlier rule-based approaches that it heralded an entire business in itself, right? In fact, initially Gmail was free for the longest of time. Even now, it looks free, but it's actually part of a bigger cost that we as end users pay. That's a discussion for another day. But when Gmail started off, the popularity with which they they got taken up was mainly driven by their spam detector algorithm. So much so that nobody talks about spam as being a big email problem. But back when email was initially available as a service from the likes of Yahoo Mail and things like that, spam was one of the biggest issues that end users faced. Okay, so that's software 2.0. Let's forward on to generative AI. What is generative AI able to do, which is beyond what software 2.0 systems were capable of? If you notice that the problem statements are the same, spam detection and things like that, right? What's changing is the techniques available. And to whom are those techniques available? They're available to the humans working in the software development lifecycle. So it's available to the users, to the coders, etc., etc. So now let's look at what generative AI is brought to the table. The data collection from software usage is definitely there, right? Nothing about that changes. Data is of different forms. You're not really changing that either. The data is getting collected into a central place. Data analysis happens, absolutely. But with AI tools from LLMs, the users no longer need to express language in the form of technology or language that technology needs to understand. They can start to articulate requirements using simple English, right, without going through technological jargon. And that set of simple requirements passed through a Gen AI tool, like for instance an LLM or coding agent, etc., right, really allows you to create software, right? So if you then think about software 3.0 as a logical next step of how software systems have evolved, with the advent of agentic AI tools, which are just the next stage of evolution of Gen AI tools, you've now got agents working on your behalf, agents which are coding, agents which are reviewing code, agents which are taking business requirements and comparing whether the code that you've written is meeting the requirements from a business perspective, agents which are quality testing your code, etc. A family of these agentic AI tools can meaningfully translate even complex requirements that the business has into code which are very simple to work with. And so the software becomes simplified because it's automatically generated, right? It's no longer human generated code which has huge amount of complexity associated with style differences, with bugs, with interdependencies which are not captured modularly, etc., etc. Instead, you've got now agentic AI tools which are building simplified software from complex requirements. And that's the middle of that's the revolution in which we are middle of right now. I would say early stages of right now. And what this really has an impact on is everything else that happens downstream as well. Not just the fact that coding as an activity becomes more automated, but also what happens to all the data that's getting collected. If the software is actually simplified, the data that's produced from it is also going to be fairly simple to understand. So maybe then data science as an activity need not be as complex as what it is right now. Instead, the feedback that simplified software can provide is in most cases going to be enough for the agentic AI tools to instantaneously take action on without going through elaborate data science life cycles. So that's a pretty significant shrinking of the software iteration cycle that happens in software 3.0, apart from all the other benefits of automation and business being able to generate software directly without having to go through elaborate coding iterations. Let's fast forward even more, right? And there is no, I would say, common term that exists in the industry today to describe this. So I'm just going to use rather, clunky way of describing it as AI as a solver of problems. So as a business user, I have a problem. I'm able to articulate the problem as a complex requirement. What if there is a mechanism that exists to take that complex requirement and directly, make a tool like a chat GPT, like a Claude, ready to solve the problem? I'll illustrate this with a demo in a couple of minutes. But let me rephrase this in a different way. So the software no longer exists, right? There is no software that's getting produced, right? There is an existing foundational model, which is obviously software, right? There is no doubt about that. But that software already exists. That's a foundational model applicable for a wide variety of use cases, not just for you, not just for that business. And what's interesting is that software can be tweaked, can be adjusted, can be instructed to solve a specific problem which has a bunch of complex requirements. And when solved, that software has automatically become capable of providing answers or outcomes which are necessary to meet those requirements without producing new children's software, without producing new code that needs to be tested or that needs to be owned, that needs to be managed or anything else. That's what I mean by AI as a problem solver. It solves the problem which is very specific, even though the AI is actually generic. So in a sense, it's making the task of taking a foundational AI tool or an AI tool in general and making it ready for a problem to be solved, so that any you know any person facing that problem again and again can just use this ready version of the AI tool and get their problems solved directly. So here the feedback from such a usage of such tools goes back to the business without requiring any data science interpretation or data workers by themselves. So it almost looks like software 1.0, or before even the all this data science related innovations happened. So it's kind of like going back to the roots, but now with a significant innovation being, there is no software to manage. There's no software to deploy. There is no CI/CD in the classical sense. Now, what's the roadmap for this kind of a you know um, um, usage of AI? I don't know the answer, right? But what I do know is, for simple enough requirements, this is already possible. So let's take a look at it with a demo. So for this, I'm going to go into the Google Cloud Console, um, go into Vertex AI, and I'll show you a playground of what I've built up using the Vertex AI Studio. So prompt management, there we go. So the spam filter problem, which we just saw some simple instances of earlier, I've tried to create um, a way to solve for this using just Gemini 2.5 Flash directly without building software. So let's take a look at what is there in this prompt in detail. So I'm going to start in the beginning. I've instructed the Gemini 2.5 Flash to function as a spam filter, and in doing so, I've also said to it that I'll be giving the requirements to meet in order to detect an email as a spam. And the Google or Gemini 2.5 Flash is free to add its own intelligence on top of it, and it needs to produce the answer as whether that particular email is a spam or not. And this will be done for every sample that I give it from then on, right? Once the tool is marked as ready. And how is it marked as ready? I, as a user, am satisfied with the outputs that it's producing. Now, for simplicity's sake, I'm not giving the body of the email. I'm just giving some metadata about the email, right? So what did Gemini 2.5 Flash do? It came up with a bunch of instructions about what it thinks is the right way to go about it. I ignored all of that, and it gave me some, you know, uh, uh, wait, yeah, it gave me basically a body of how I can provide this data so that both of us have a common understanding. And then uh, it will, it said it will do a bunch of things related to spam detection, which is fine. Then I gave it that I'm going to give it only a structure of email which has only three properties: the sender, which is the sending email domain, email address, the subject line, as well as the date time. So the rules that I want to provide to it, I've also given it to it, given it to it. One is that anything that originates from Russia as a domain, which is star.ru, using regular expression syntax, I want it to be marked as spam. I'm also giving it a whitelist of users. These are known users whom I don't ever want to be marked as spam. Emails from them should not be marked as spam. And then for any email that does not meet these two requirements, right, or these two constraints, Gemini is free to use the intelligence that it already has to do the spam detection. But when it does it, I want it to provide valid reasoning for every time it's making a choice or making a decision. So it said that it understood, and then it ordered these rules in a way that allows it to process emails. So it said the whitelist should come highest priority, the blacklist is also high priority, and then its own intelligence for undecided emails. Okay. Now I start giving samples. The first sample is hello, important is a subject line. It comes from a123@gmail.com, date time is blah. So it's able to reason and says, look, it's not spam because the sender is part of your whitelist. Notice what happened here. Now, the flow looks very natural. All of us have used LLMs before, so this seems like a perfectly natural way to work with them. But what you've really done here, what I've done here is I've gone from having requirements, which I would normally create a requirement document and circulate it to a software team. The software team would go build a Python code or a Python model, deploy the model into an endpoint. The endpoint would then get exposed as part of the testing. Then the email body will get sent as a JSON. Then the endpoint will return back with yes or no. And throughout this entire process, the entire software needs to be built, managed by managers, product managers, by engineering managers. It needs to be QA tested, etc., etc. All of that is gone. Almost all of it is gone, right? I've now got Gemini, which is a general purpose foundational model. I've made it specific to what I want in terms of requirements. The requirements are very simple, right? That caveat is always there, right? Keep that in mind. And I've gotten it to work on samples that I'm providing to it. And it's able to produce a binary output which I'm desiring of not spam or spam, right? So the creation of software as a step, which was absolutely necessary for the last 40 years, 50 years, is now gone for this simple requirement. Next requirement, next sample, like whatever at gmail.com, basically it's not in the whitelist. I'm giving a big subject line which says important, etc., etc. So it says this is spam because the whitelist check failed. The blacklist check also failed, but it uses its own intelligence and says that important is excessive capitalization, so likely spam. Like that, there are a bunch of samples. Now, great, right? I need to now use this learning that Gemini has brought in into my inbox software, because that's where the spam detection needs to be done, right? If it's spam, I need to move the email to the spam folder. So how do I go about it? And to do that, what it says is I need to, work with an API provider because it needs to be packaged as an API. What I have now is a chat interface, but it needs to be packaged as an API. It's suggesting other options, obviously, apart from Gemini itself. Uh, Tongue-in-cheek, it's also a robust option, which is very interesting. Then you need to build webhooks using, Node.js or Python or whatever middleware, and then have email body be exchanged to this API, and then work with the output that gets produced and sent back to the inbox software. And then finally, the prompt system needs to be robust, right? So you've got to do a standard templatizing of the prompt, engineering of the prompt, etc. So in essence, you still got to write software, right? And the software is necessary for operationalizing the business process, even for something as simple as a single rule or a two rule based spam detection system. But the future is something that you get a glimpse of here, where you go from requirements to working software, or rather, working outputs from a general purpose software without building new software, without instantiating new software for it. That's what I wanted to show as an example of AI as a problem solver. Okay, so if you now come and look at what's the generalization from here, and this is the last slide. I want to talk about what this means for trending. I mean, for trends in the in the space of ML operations affecting you as students of this course in the near term. The crucial word is near term. Okay, so proprietary AI platforms. I think they are great for startups because they provide the bells and whistles required for all the different aspects of MLOps to happen seamlessly under one roof, with full transparency, with full linkage, automation, etc. Google Vertex AI is a good example. But the more enterprise you go, the more regulated the industry is, the more diverse the data estate is, the more multi-cloud the footprint is, or multi-data center the footprint is, you would find that DIY approaches using open source and open standards is the norm, right? So be prepared for that. One of the great examples of this, which I found very interesting to read about, is Walmart's Element AI platform. The link is here. You can go look at it, or you can Google it up. it's got a bunch of multi-cloud components, hybrid components, etc., etc. But the more interesting thing is Walmart has shared its learnings about how it architected for these systems and the choice of different technologies. There were a couple of proprietary technologies they used, but they articulated the reasoning for it, and it's quite instructive. The second trend, right, is going to be the fact that centralized access to quality data is going to be an absolute premium. It doesn't matter what problem statement you work on. It doesn't matter whether you work with foundation models as users or fine-tuned models as users, or you're building foundation models yourselves, right? The uh, curated data sets are going to be what differentiate efficient, effective outputs from garbage, and having access to it in a centralized form so that a bunch of workers, bunch of AI engineers can work on it and operationally manage it and give the best results. That's going to be the key requirement for an organization to be successful in the modern AI world. So it cannot be stressed enough that this is a critical prerequisite. The third aspect is domain specific training is going to be what separates the regular run-of-the-mill usage of tools like LLMs from the really effective usage of AI, right? So you can either take foundation models and do domain-specific fine-tuning, or you take fine-tuned models and do domain-specific few short examples learning, right? So those are variants, but the fact that domain-specific natures or domain-specific examples are required, or domain-specific engineering is required, is a absolute differentiator in the near term. One really interesting case study here is Replit's LLM. So they took the foundation models and they built their own LLM for code as a service. So Replit, some of you may know, is actually a code as a service company. They provide tools for developers to build a lot of really effective code using prompts, using simple requirements. So take a look at this link as well. And one of the most important observations in my view is the fact that in this future where agents are deployed left, right, and center, not just for software, but also for communication, you are no longer going to be having patterns of usage where businesses try to sell to consumers and consumers want services and goods from businesses. In other words, the B2C business model is going to get completely upended, right? Obviously, revenue or money still flows from consumers who are consuming something from a business. So in that sense, the money flow is from consumer to business. But you will see increasingly more and more that the interactions that happen towards that money flowing is going to be from agents to agents, right? That's what I am referring to as A to A. It's going to be your agent as an individual, your agent running on your Android phone, on your iOS, on your device, talking to the agent of the business, which is going to be agent of the bank, agent of the telecom company, agent of the government, right? And these are all not James Bond style agents. I'm talking about multiple families of agentic AI tools which are getting deployed by your edge device for you, but also by the business for themselves. And these agents are communicating with each other and negotiating and contracting and working out the terms, working out the price, working out which products to buy, what products to discover, which products to sell. Imagine what this means, right? APIs, which were how information got exchanged in rigid, well-defined manners, now has gotten already replaced by MCPs or model context protocols. What is an MCP? MCP is just a glorified version of an API. That's one way to think about it. But if you think about it in a completely different way, in this way where agents need to talk to each other, not humans needing to talk to agents, or humans creating software which need to talk to other software being created by other humans. That's no longer the case. It's agents wanting to talk to agents, which means the agents need to understand the semantics of other agents. The semantics is a lot more important than the syntax. API coded the syntax up, right? API enforced syntax. Whereas with MCP, I don't need to understand the specific syntax. I need to just understand the context. And the context is basically where the meaning is. That part of the evolution has already happened. But what's going to happen even more is that the transaction data is going to be of so much more value, orders of magnitude more value than the interaction data. So if you look at how big data itself came about as an origin, most of big data was interaction data. Interaction data meaning humans interacting on a website with a let's say an e-commerce portal like Amazon or Flipkart, or humans interacting with other humans like WhatsApp and Skype and messaging services like Instagram, etc. Those were humans producing data in their consumption of other humans' data. That's interaction data. And if you look at a typical uh, data production cycle, interaction data was 1,000 times bigger than the transaction data. 1,000 is just a number, right? Basically orders of magnitude bigger. Whereas what I mean by transaction data is when actually money is involved, right? When a good is purchased, right? So the interaction data that goes towards purchasing a good is so much, right? So many, so many things that you click on, so many, information linkages that you follow, but then finally you just buy once, right? So the world of big data was built on interaction data. The world of advertising, marketing, all of it was built on interaction data because all of it revolved around the individual, understanding preferences and marketing to them. But imagine now that individual is no longer a human being. It's an agent that's communicating on behalf of that individual. And the agent is actually generalizing from other agents that it's talked to or other individuals that it's learned from. So the individual's preferences are no longer getting adequately represented by the agent, which is talking on behalf of the individual. So then the only vote which is trustworthy of the user's preference will be when the user spends money, because the agents don't have money. It's the users that have the money. So transaction data is going to become super important, way more important than interaction data. And so in this world, agents talking to agents will become like a significant upheaval in the way that commerce happens, in the way that most platforms are operating today. So with that, I'll I'll close. Hope you enjoyed this course, and maybe some of these trends will not stand the test of time, and who knows, something else comes about which is far more important than some of these observations. But at least in the near term, it pays to keep in mind that there's a certain way in which technology is evolving, and you've got to continuously learn and stay abreast as MLOps engineers. So happy operations and all the best.